மயில் அனுப்பவா?
அதை அப்படியே ஆர்ஐடி ஐஎஸ்டிக்குள்ளே கொடுங்க. அப்போ
யாருக்கு அனுப்ப?
அமுதன் தம்பி உள்ளே இருக்கும். வந்தாச்சு. இந்த இது யூடியூப் லிங்க் மாற்றிருக்கு. சரியா? சரி, ஓகே யூடியூப் லிங்க்
அனுப்பிட்டேன்.
உள்ளே தான் இருக்கும். இல்லை உங்களுக்கு அந்த ஸ்க்ரீன்லாம் தெரியல. இல்லை நீங்கள் எப்படி இப்போ ஜெவிந்த் வருவாரா மதியானம்? ஓகே நீங்கள் அந்த இன்ட்ரோடக்ஷன் கொடுத்து ஸ்டார்ட் பண்ணிடுங்க. சரியா? இல்லை அது அந்த இது இருக்கா, ஒன் பேஜ் ரைட் அப் மட்டும் இருக்கா? ஓகே டைரெக்டாக வெல்கம் பண்ணி அவர்கிட்ட கொடுத்துட வேண்டியதான் செஷனை. சரியா? அவர் உள்ளே வந்திருக்காரான்னு பார்த்துடணும். சரி ஓகே சரி, நான் பார்த்துறேன். சரிங்களா? அமுதன் சாப்பிட்டுட்டு இருந்தாப்புல. நீங்கள் ஒரு தடவை அமுதன் கிட்ட கேட்டுருங்க. ஜி அதை மெயில் பண்ணிட்டீங்களா? இப்போ ஒவ்வொருத்தராக உள்ளே வர்றதுக்கு ஏதோ இப்போ பண்ணியிருக்காங்களோ, நம்மளை கேட்டுக்கிட்டே இருக்குது. அட்மிட் கொடுக்க வேண்டியிருக்கு. யார்? ஜெபிந்த் இல்லை உள்ள. அவர் ஏதோ புயல் அடிக்குது, மழை பெய்யுதுன்ட்டாரு. ஓகே நீங்கள் முடிச்சுட்டு வாங்க.
சொல்லிட்டு வந்தேன். கையில் பாரு சொல்லிட்டு வந்தேன்.
மனிதர்கள்
அவனை பற்றி எனக்கு ஏற்கனவே தெரிஞ்சு நான் ஒரு மரம் பிடிக்கிறேன் முடியாதுன்னு. இப்போ இப்படி இந்த இடத்துல என்ன லாக் பண்ணான்னு வச்சுக்கோங்களேன், இதோட அடுத்த ஸ்டெப் போகணும்னு யோசிப்பேன் நான். இது இன்னும் இந்த ப்ரோக்ராம் போராட்டி இன்னும் அடுத்தாங்க நாங்களாம் சேர்ந்து ஒரு ப்ரோக்ராம் நடத்தி அழகாக வெளித்தள்ளி விட்டுறோம். என்கிட்ட ஏற்கனவே இப்போ 1200 அங்கே ஒரு 2000 கிட்ட 2500 பார்ட்டிசிபெண்ட் லிஸ்ட் என்கிட்ட இருக்குது. திருப்பி கொண்டு வர முடியாதுங்களா?
கண்டிப்பாக முடியும். ஜி அவங்க வீடியோ நம்மளால மியூட் பண்ண முடியாதா?
அது மியூட் பண்ண முடியாது, இப்போ நம்மளால தான் பண்ண போகிறோம்.
இப்போ ஆறுமுக சிவஞானம் மியூட் பண்ணப்பா.
உங்களுக்கு கால்
எனக்கு
ஹலோ காலேஜில் இருக்கேன், சொல்லுங்க. பிரச்சனை உங்க குருநாதர் தான் பிரச்சனை. வந்து சொல்றேன், ஈவினிங் வந்து வீட்டுக்கு வந்து பிறகு பேசுறேன். இல்லை வீட்டுக்கு வந்த பிறகு நான் சொல்றேன் டீட்டெயிலா. இப்போ வராது.
யூடியூப் லிங்க் மாற்றி
ப்ராப்ளம் பண்ணாத அளவுக்கு ப்ராப்ளம் வராது. யூடியூப் லிங்க் மெயில் அனுப்பிச்சிருக்கேன், செக் பண்ணிக்கங்க. அதான் ஃபார்வர்ட் பண்ணுங்க. இல்லை நான் ஒரு மெயில் அனுப்பிச்சிருக்கேன், யூடியூப் லிங்க், புது யூடியூப் லிங்க், ஒரு புது யூடியூப் லிங்க் அனுப்பிச்சிருக்கேன் உங்களுக்கு. உங்க மெயில் வந்திருக்கும் RITISC-லேருந்து. சரி சொல்லி கொடுத்துருவோம். அதெல்லாம் பிரச்சனை வராது. ரைட் ஓகே. சரி பரவாயில்ல ஜி. அதாவது அமுதன் ஒரு இடத்துல இவங்க நம்ம இன்டர்வியூ பண்ணாங்க, நம்ம வேற மாதிரி கொண்டு போவோம், கவலைப்படாதீங்க. ஈவினிங் வந்து பேசுறேன். ஈவினிங் வந்து பேசுறேன். ஓகே. லைவ் கரெக்டாக தான் போயிட்டு இருக்கு.
பிசிசியில் போட்டால் ரிப்ளை ஆல் போட முடியாதா? ரிப்ளை ஆல்
பிசிசியா? யூபிஎஸ்சி ஸ்டாப் பண்ணி வச்சிருக்காரோ?
கரெக்டாக 55 ஸ்டார்ட் பண்ணலாண்ணா.
உங்கள் ஆள் இருக்கா ஸ்டார்ட் பண்ணுறது?
அங்கே இப்போ பிரபாகரன் இது இன்ட்ரடக்ஷன் மட்டும் கொடுத்துட்டு போயிடுவாப்புல. இப்போ என்னால் ஸ்க்ரீனுக்கு இதெல்லாம் வர முடியுமாச்சு? இப்போது வேறு யாராவது இன்டரப்ட் பண்ணால் அவங்கள ஸ்டாப் பண்ண முடியுமா?
பண்ணலாம்.
இப்போ இந்த ஏதோ என்னன்னு காட்டுறானே, இவனை எப்படி தூக்குறது?
நம்ம இதுக்குள்ளே வந்து முடிஞ்சு வச்சு அவ்வளோ அந்த இடத்துல நம்ம இது அவ்வளோதான்.
அது அவர் பார்த்துக்கிறேன்.
விட்டுருங்க, நம்ம பார்த்தா பிரச்சனை இல்லை. பார்த்து
அமுதன் சார். Kumar sir.
Amudan is not available here.
Okay. I'm audible, sir.
Audible only.
Yes sir, it is audible, sir.
Let me wait for another just 5 minutes.
Okay, sir. We will wait up to 3. We will start.
Oh, fine.
Okay, sir. 3 play we will start, sir. Now the participants are joining now.
Yes, sir. Our resource person also came, sir. Name of.
Okay. Let me check their screen is what visible. He can able to present.
Yeah.
யூடியூப் லிங்க் என்ன தெரியுதுன்னு பார்த்துங்க. நான் ஸ்க்ரீனை ஷேர் பண்ணியிருக்கேன். வாங்க வாங்க. Prabhakaran sir. Prabhakaran? Mr. Prabhakaran?
Yes, sir.
Now you ask our resource person to share his slide and then give a brief intro. Let me start the session.
Yeah, sure.
நீ பேசுங்க அவர்கிட்ட. நீ பேசுங்க, நான் என்ன சொல்கிறேன்.
Good afternoon, Bala Ganesamurthy sir. Can you able to hear me?
Good afternoon, sir.
Sir, kindly share your PPT sir through Prasanna now.
Is it viewable?
Hi.
Yes sir.
Is this okay to everyone?
Fine
No, sir.
Fine sir.
Those who are not able to view the presentation, kindly pin ABGM.
Okay, sir. Everyone can visible, sir. Shall we start, sir? Sokmar, sir?
Yes, formally you just give a brief intro about our resource person. Let me start the session. There before I want to convey one message to the participants. Don't panic about morning feedback and all. So that first two sessions feedback and all that is what completed. So anyway, now you just actively participate and then listen. Third session at the end you are having sufficient time to give your feedback. You just kindly cooperate with us. Regarding morning session, no need to put any kind of email to us. So I just hand over the session to Mr. Prabhakaran.
Yes, sir. Good afternoon, everyone. After lunch, we are going to have one new session on computational fluid mechanics. This time, I'm going to introduce our chief guest. So, Mr. A. Balaganesamurthy, Digital Engineering Services and a Solution, for giving lecture on computational mechanics as our 5-day Webathon on future topics in mechanical engineering. I'm going to give something about chief guest. Sir having 13 plus years experience in software coding and application development. He has more extensive knowledge in computational mechanics and CAD CAE tools. He got more than 5 awards, especially best award in group lecture, best lecture award, and more than certifications like Six Sigma, Green Belt, etc. He has done in engineering mechanics in IIT Chennai. He has done Bachelor of Engineering, Mechanical Engineering, Government College of Engineering. He published more than 2 journals and 4 international conference and 2 more national conference. Still, I need more than 1 hour for explaining in profile. So, with a bit of introduction, I hand over once again, on behalf of Ramco Institute of Technology, you all mechanical engineering, grand
Sir, excuse me, sir. Sir, sorry for the interruption. Hello, sir. There is a voice breaking now.
session to
Hello,
introduction our session to our chief guest, sir.
sir. Breaking voice.
Okay, I think Prosen has given the introduction and he has some voice interactions between his chief guest introduction. I hope everyone can hear me. This is Balaganesha Murthy. I'm presenting the computational mechanics topic here. Can everyone hear me properly?
Yes, sir. Yes, sir. Now it is okay, sir.
Okay, please others keep in mute, and if you have any doubts or clarifications at the end of the session, we'll having some time for having some discussion as well as clarifying your thought process. Thank you so much for joining me into this Webathon session, and thank you all for joining this session. Here, this is a huge topic. I could not able to give you the sufficient information during this 1 hour session, but anyway, I'm trying to give you the in-depth knowledge of my understanding as well as my experiences into small in a nutshell for understanding for making you to have a glance on computational mechanics. So I have selected the computational mechanics into 3 topics, like an overview of computational mechanics, the research directions and the interest for the current fields, how to elaborate the research so that we can have some solid foundations in the computational mechanics fields. Then I wanted to give you the overall aspirations for the students' point of view, how the industrial expectations for career aspirations, how the students can start their life from their second year and third year and during the final year projects, and even they continue for research as a MS or MTech in any global institutions or universities, how they can go further into the industrial needs. So these are the major topics. So I would like to cover these major topics into subdivisions, like the overview will be having introduction of the computational mechanics and what are the branches of computational mechanics in industrial aspirations. Then how the subjects are involved into the computational mechanics, so that the computational mechanics have been evolving for the last 3 decades. And the second major topic is research directions. So that will be including both current trends and the future of computational mechanics. So it will be giving the brief introduction about the research interest of computational mechanics. Then I'll be going for detailed things for industrial needs, how the industrial applications are developed using computational mechanics, and what are the processes involved. Then I'll be giving a detailed overview on design, computational engineering, aided engineering, and CFD things. How the expectation from industries, so that the career for students would be a fruitful thing and fulfilling the needs of industries. And then finally, a small intro for the career for students.
Sir, your screen is not visible.
Okay.
Hello, participants. Hello, sir. Hello, participant. Can you hear me? Sir, your screen is visible, sir.
Okay. Yo, can you please pin me so that everyone can view my screen?
Participants, please select it as DGM, sorry, ABGM and you will in the screen, you will be in the center of the screen, you will be having 3 icons. The first one is pin icon, the second one is mute icon, then third one is remove icon. Please click the first icon. Click it. Once you have pinned the presenter window to your screen, you will not be having any disturbances from other internet. Okay. Sir, you can present, sir. Everything is fine, sir.
Okay, fine.
Sir, PPT, sir. For the PPT, yes. Fine. Thank you.
Okay. If you see the overview of computational mechanics, we usually mention two people. One is Jinkovic professor, and the other one is Professor Timoshenko. So these two people considered as the legends of computational mechanics, from where we are getting a lot of computational mechanics solutions from the beginning, and still we are sticking on their policies and principles for analyzing and creating new algorithms and equations, whether it is a continuum mechanics equation, or it's a biological systems, or it is a probabilistic equations, whatever, we are depending on them. So Professor Jinkovic used to call us a father of finite element methods. So it's a fundamental thing for all computational mechanics problems. And Timoshenko know him as a plasticity and elasticity king, and he's the father of modern engineering mechanics. So if you see the computational mechanics, it is a discipline where it is compromising all fields of disciplines, kind of mathematics, physics, mechanics. So I can say computational mechanics is a discipline with solving problems on the basis of numerical approximation methods. You please consider this: computational mechanics is the approximation methods, and it is not the exact solution how we feel in the experimentation or in the current fields. So this computational mechanics will be having the discretization of some of the underlying equations. The equation could be integral, partial, or differential equations, or any kind of, or combination of any of these things in the solution space, considering space and time. So the computational mechanics can be divided into many branches based on their application, based on their theoretical aspirations, based on the solution methods followed. And so here I'm just dividing these computational mechanics into few divisions based on the theoretical methods what we follow. If you see computational mechanics, it's a growing environment in the last 3 decades, and we are in the fourth decade. In the last, at most, from the 1970s onward, people are getting involved in finite element methods and computational mechanics when they are getting huge type of computers having a large number of RAMs and processing units. So they wanted to simulate the experimental things in the environment of computers, and they wanted to develop equations based on the needs, boundaries, forces, atmospheric temperatures, or whatever the parameters we wanted to consider. So when they have enormous amount of computational systems, they wanted to develop the computational mechanics field. So in the last 30 to 40 years, it has been evolving like anything in the world. And nowadays we have almost 500 plus computational tools for helping us in design, solving the computational problems, and analysis, presenting the computational methods as well as the results. Apart from this, the universities having research and experimental methods. So they are also used to develop a lot of computational packages for daily uses of students and research people. So I am dividing this computational mechanics into branches like solid mechanics, fluid mechanics, material simulations, biomechanics, multiphysics methods, fracture mechanics, multiscale, particle and mesh-free methods, synthesis of material system, and finally probability analysis. So these are all very few and mostly used in between the researchers as well as from the commercial environment. So this technology having predictive methods and the performance of various products which are important for the research and development in the industrialization as well as into the societal needs. So this is giving the branches of computational mechanics. So I'm just moving to the what are the subjects involved in computational mechanics. So as I mentioned in the earlier slides, this has been evolved from the physics and mathematics, and this has been coupled with the computer science, and hence the computational mechanics has been evolved in the recent days. So it is a combination of physics, mechanics, mathematics, and computer science, and it is still encompasses applying numerical methods to various problems in science and engineering. And nowadays, it is giving a lot of exposure to the researcher development as well. I'm just concentrating onto the research directions of computational mechanics with the current trends. So, if you consider computational mechanics, it has been evolved recent.
Sir, sorry for the disturbance, sir. Sir,
Yes.
Prabhan, sir, check your sides and the PPT is not visible, sir. Prabhan, sir, and Sogama, sir.
Sir, PPT is visible to all the participants. If you are not able to visible, kindly pin ABGM.
All the participants are requested to pin the presenter screen, sir. Then only you can able to continuously see the screen. If any disturbances arrival, you cannot able to disturbed, or otherwise you can able to continue your learnings. So you just
Okay, sir, okay, sir.
Okay, let me continue. So, in this slide, I'm just giving you the current trends of computational mechanics, how it is being evolved into the addressing the current needs of industrial revolutions. So, the important point for implementing the computational mechanics is identifying the new models. It could be a physical model or biological system based upon quantum mechanics or molecular science or biological systems. But anyway, the model is an essential one which needs to be incorporated or coupled with the concepts. It could be the physical concept or the mechanical concept or the probabilistic concept or anything, so that we can incorporate that model. It is nothing but a mathematical model. The model, it seems mathematical model. So the model could be interdisciplinary in nature, and it is reflecting the combination of concepts and methods used in the numerical methods. And finally, we used to have the principles that often span several areas of mechanics and mathematics and computer science to bring the solution. In computational mechanics, with the current trends and the current availability of computers and their infrastructure, we could be able to compromise our results to 95 to 99% of efficiency, and we are reaching so. So we can routinely develop the computational models as of now with the degrees of freedom from 5 lakhs to 1 crore. If you see a twin tower collapsing, or any hurricane, or any Toronto, or any kind of probabilistic analysis also, we could be able to achieve more than 95% of efficiency using computational mechanics nowadays. In this slide, I have just had briefing about the updated technologies which are coupling with the computational mechanics for bringing the finest solution. The graphical processing unit, data analytics, artificial intelligence, cloud technology, generative design, simulation data management, process automation, enhanced usability of features, optimization techniques, and mobility services with new material science and new materials database. So we could arrive n number of solutions with a similar design and similar methods and models, whatever we propose. If you consider generative design, with the help of boundaries, with boundary methods, what could be the forces applied, what could be the material to be used, what could be the material properties. So based on these fundamental elements, we could generate thousands of designs in a less than of half an hour or 45 minutes. So with the help of the computational infrastructure, we could arrive such kind of results. So these results are available currently available. So as an industrial person, I could see this computational mechanics have been giving the finest solution in the recent days with the help of cloud technology and artificial intelligence. That is nothing but the predictive methods. If you see the biomechanics and biological system, that is a concept called predictive surgery, which is having data analytics and artificial intelligence methods. If you see simulation data management, it has plenty of results already available, and what based on the parameters we have considered and the results we have seen, we could make the simulation data management so that unnecessary wasting of time in simulating different type of environment and different type of results using forces, parameters, boundaries fixing, and the environmental changes. So with all the help, we could able to generate a less number of simulation for enabling our results in the quicker manner. If you see the graphics processing unit, we could see the changes between the elements, how the stress and strain deviations from elements to element or from edge to edge and between the contact. So that kind of the linear transformation of stress strain curves between the elements and between the contacts could be easily identified. And while using the CAE tools with the help of enhanced usability features, I can give you a small example here. While working in the PPT or Word, if you select a particular word and right clicking, you can see n number of features. So without going to the menu bar or features bar, you can at the point of place you can modify your font size, the color, the caption, all the footage and the footer and headers. All those things could be easily handled. So those kind of features are called enhanced usability features, and the current available commercial tools are having a lot of enhanced usability features to minimize the efforts of user, that means research people or students or industrial persons, to achieve their results in the quicker manner. So the future trends of computational mechanics evolving in many interdisciplinary areas. So I am briefing about the few areas where the current research are going like anything. That is one is called virtual design. This virtual design is it's one of the finest area in CAD and CAE environment, where even the CAD tools nowadays, Creo or CATIA or Autodesk or whatever design tools you are using nowadays, having nothing to have a separate CAE tool. In the CAD tool itself, you can develop a minimalized CAE conceptual design, and you can evaluate the parameters and the results, and you can modify the design accordingly. So the virtual design is one of the computational mechanics research area which is growing like anything. Then multi-scale phenomena, including bridging the molecular to atomistic level for enabling the material level discontinuity and material level deformations to analyze the large scale deformations. And model selection and adaptability, very large scale parallel computing using infrastructure of computers, and biomedical application. Nowadays biomechanics becoming a vital role in most of the conceptual as well as the applicable application oriented medical areas. So if you see predictive surgery or application of mechanics to the cell level, bone level, and nerve systems level, and creating biological models are very easy compared to the older region or older periods. And when comparing to probabilistic methods, if you see natural hazards, anything kind of hurricane or tsunami or any earthquake kind of things, we could be able to analyze or what would be the collapsing environment or what could be the hazards before it happens. So when considering the architectures or building or any power plants or atomic stations, we could be able to create stochastic analysis as well as the probability methods, and the computational methods and the current infrastructure of computers helping lot for creating new research areas using computational mechanics. So I'm not giving enough time for research directions because this is a very narrow area based on the interest of the students or research people or the industry. It could be elaborated. So I'm just stopping here for the research directions of computational mechanics. I'm just moving to the the combination of interdisciplinary areas. As mentioned, the molecular dynamics and material science, biomedical systems, and quantum mechanics, with the current trends, the research direction of computational mechanics is huge. The only heuristic area we suffer is creating a model and the right model and selecting the right equations and following the right method. Parameter or geometrical parameter, topological characteristics, and then using the conditions like boundary conditions or finite element conditions, whatever. So appropriate model with the right method and the right boundary conditions, we could achieve more than 95% of results, and that could be our solution. So I'm just moving to the industrial aspirations of computational mechanics. So, if you consider hugely into industrial needs, there are four major areas: finite element analysis, finite element methods application, and computational fluid dynamics (CFD) area, and multi-body dynamics, then optimization and simulation environment. So if you see combination of these four, I'm just listing out the various applications and analysis types used in various industries. So I have gone through aerospace as well as automotive sectors in the last 12 to 14 years. I have experience on the research of few applications. I work with Hypermesh, Altair Engineering, and MSc Software, MSc Pattern, Astron, or Mark Mentor. Those are all nonlinear analysis tools. Then I worked with in-house application development for Bell helicopters. It is related to composites analysis tool development. So I used to develop applications using OOPS concept, and it has both front pre-processing as well as the post-processing concepts. I have also worked with automating the pre-processing and post-processing concepts for NVH and fatigue analysis. So, considering all these experiences, I could give some suggestion on the industrial needs of computational mechanics. So it has been evolved in a lot of analysis, from static analysis to nonlinear multiphysics analysis. But few of the analysis usually common in the environment, and most of the commercial tools have been being developed for achieving these analysis types. Stress and dynamic analysis for FEA concepts, CAE, mostly into the structural analysis concepts, thermal and fluid analysis for aerospace application, and outside of automotive sectors, kinematics and kinetics, which is comprising dynamic analysis of mechanisms. So it is under multi-body dynamics. Acoustics, it's another automotive and aerospace sector. Uh, Simulation of manufacturing processes like casting, molding, and die press forming. Particle simulation environment. Multiphysics analysis using multiple simulation phenomena, and optimization of product and the process. If you see the optimization technique and new product development area, this simulation of optimization techniques is huge. If you have any experience with the OptiStruct tool, it will be giving lot of intuitive application and intuitive methods for providing solutions for your design environments. So this optimization technique have been evolved with the computational mechanics for bringing our solution into finer region. So I'm touching mostly into the solid mechanics region because I'm involving with engineering mechanics and structural mechanics field. any of the CFD tools in my current industrial needs, but I have some limited knowledge on that. Both the CAE structural as well as the fluidic interactions, FSI, fluid structural interactions, is also one of the field for computational mechanics to evolve aerospace applications. So if you see the computer aided engineering fields for structural applications, majorly we see two environment, one is aerospace as well as automotive sector. If you see the recently, I have been working with Ford, Caterpillar, Daimler, and other major automotive sectors, global giants. So we used to develop methods as well as solutions for their CAE engineers, analysts, and we used to fine tune the results for their application and their requirements. So it is usually for various kinds like NVH, fatigue, durability, multi-body dynamics, full scale analysis, static analysis, nonlinear. So all these are all having built based on some commercial tools. So those commercial tools are available for researchers as well as students in the current days with a limited boundaries. We can use those applications as a interest, as a research point. So if you see the industrial needs, it is evolving from the physics basically. It is slowly going into the mathematic concepts. It is having a lot of, if you go into the computational mechanics deeper, you need a lot of interdisciplinary areas. If you want to use any particular area, you can describe your areas of interest and the relevant physics, mechanics, and numerical concept to be used. So so this is the process we usually follow in all analysis point of view. So we usually import the CAD model. So before that, we usually generate the CAD design with the help of commercial available tools. We usually go for CATIA, Creo, or in the help of Hypermesh or any other Unigraphics or NX, anything could be used for that. And once it is done, we usually go for the importing the CAD model into the pre-processing environment, and that environment usually called for meshing the model. Once we meshing the model, and we usually go for 1D, 2D, and 3D. So those aspects would be developed with the help of that particular commercial application. Between the tools, the 1D model, 2D models, 3D models would be, the naming or the nomenclature would be changing, but the fundamental concepts would not be changed. It is constant. Once we generate the meshing of the model generated from the CAD, we usually go for the material properties and assigning the material properties to the design, because our design usually have lot of components or assemblies. So each would be having different type of material, and that material would be having different type of properties. So by fine tuning the material properties and material selection, we can fine tune, we can reach our solution easily. And then we go for the constraints. So the boundary conditions to be applied at appropriate places. If it is a contact problem, we have to select the element level and node level constraints, and then we go for applying the forces. There's a loading and forces, pressure, or other temperature, or whatever the phenomena that we are going to consider for that application. Then once we set up, this whole model will be exported to a solver. So we usually go for the linear and non-linear solvers. So in commercially, we usually go for ANSYS, Abacus, Nastron, or Radios, or whatever CFD, Fluent, or anything. So those parameters, whatever defined in pre-processing level, have been taken care in the solver level. solver environment. So that solver environment our stress strain curve phenomena and our finite element concepts all used for generating appropriate results and post then our areas of interest, whether it is a strain or stress or strain or temperature or electromagnetic field or near field communication areas or electrical environment or biological needs. So whatever the need that could be arrived, and by applying the solver to run, we can getting the nodal level or elemental level results. Then based on the results, we could able to examine the results with the help of post processing tools. There are n number of post processing tools. They are coupled with the pre processing, or if you see ANSYS or Abacus, they are all having pre processing solver and post processing capabilities. Otherwise, we could go for separate post processing tools for examining our results. Then based on the results evaluation, we could arrive PPTs or hotspot evaluation or animations kind of presentations could be arrived. I'm just giving the overview of our process, whatever we usually follow in a CAE analysis perspective. I hope this could be useful for bachelor level students as well as the master level students when they are going for simulating a practical environment using commercial applications. So I hope your current curriculum would be giving this kind of exposure to the students. So as I mentioned, the process universally followed in the finite element analysis be having three major phases. One is pre-processing phase, solution phase, and post-processing phase. The solution phase is also called the analysis phase. In the pre-processing phase, there are majorly four components. One is defining the type of elements, that is the meshing, and defining the properties, that is assigning the material properties. Then model creation, that is nothing but the boundary condition as well as the applying the load phenomena. Then defining the mesh density, it is additional parameter with the help of we can fine tune our results. And in the post processing method, it has the three components. One is graphical output based on the solvers, and we can go for numerical output as well. We can define our upper bound and lower bound, and we can define the graphical environment there, and then we can go for the animated output for easy understanding of the deformation of product or deformation of assembly. And here I'm just giving a few of the major commercial application used among the research people and industry wise. I also added one more software developed by our ISRO people. It is Indian made make in India concept. So Indian made computational mechanics package that is called Feast. It has also all the, it is a multi-physics tool, so we can use for structural mechanics or structural application or CFD or any electromagnetic or biological systems. Then Siemens having a PLM tool, we're having NX as well as solving solvers. ANSYS, pre-post and solving coupled tool. Dassault system is a French company who is having the CATIA as well as Abacus called Simulia. MSC software having Patra, Nastran, Mark, Mentor, Multibody Dynamics tool, Adams, a lot of things. Altair having more than 24 applications, and still they are evolving into new application development area. And uh, according to my knowledge, Altair, Dassault system, ISRO Feast are providing student version for getting exposure to the CAE tools, CAE application, and they are also providing lot of examples, walkthroughs, and Altair is maintaining a university for students, and they can download almost 14 plus ebooks, and they could interact with the university, that is the industrial people, lively, and they have a lot of webathon, hackathon kind of programs, and they do have some system level cloud based CAE application development for students. So similarly for PTC Creo, ESI tools, console multiphysics, beta CAE, ANSA Metapost, or Tora engineering. There are a lot of nonlinear analysis tools also available. So I suggest for students to have knowledge on static analysis with the limited degrees of freedom and boundary methods. So I have given some of the analysis types which are used in the industrial needs. If you say automotive or aerospace sectors, these are all the analysis types. Mostly almost 80 to 85% used everyday point of view. If you see automotive sector, it will take at least 5 to 7 years for bringing a car into the market. If the person is who is working nowadays with the updated infrastructure of computational methods and computer infrastructure, it could be reduced to 5 years or maximum 4.5 years. That's all. So with the available infrastructure, available concepts and theoretical methods, we could arrive a new car with a new design and all new components. It will take at least 4.5 years to 5 years. So the computational mechanics is a steady and slowly progressing environment, but it has a lot of definite aspirations in the fields, aerospace as well as in the automotive field. If you say aerospace field, it will take at most 15 years for evolving into a new product, new area, new product design and bringing into the market. So if you want to develop your knowledge in computational mechanics, or if you want to aspire your career in computational mechanics, you have solid foundation now and you have definite future in the nearby years. But you have to define your areas of interest in any one of these analysis. Every field, every analysis, each and every analysis having a stream of knowledge to be gained. So based on your interest and based on your aspiration in your career, you can select any one of the tool, any one of the concept, any one of the method, any one of the uh, following up of the current fields. For students as a career, I suggest both CAD and CAE CFD areas. So the work nature would be for CAD environment. If you take Daimler, or if you take Renault Nissan or Ford or Kia Motors or Hero or Honda environment or whatever aerospace, if you take General Electric or Rolls Royce or Bell Helicopters or Textron or whatever kind, or if you take a defense DRDO or if you go for spacecraft kind of ISRO or NASA. So wherever you go, the work nature and application of computational mechanics would be similar because the fundamental is same. So we are going to apply in different environment with the same procedure and methods. So if you take a design environment, usually you go for design and drafting of components, new product development, new design, new conceptual design, rendering, and you can end to end of your car from the front bonnet to the backside crash pause. You can design all the components. Even for wire harnessing also, Creo and Katia providing lot of applications, a lot of software packages. So the work nature would be you have to develop a new product with the help of commercially available tools, but you should have the fundamental knowledge of graphics, engineering, design, and theory of machines. So a few of the software packages I listed here are CATIA, SolidWorks, AutoCAD, and Creo. Now pre called Creo. So the main thing is new product development. If you see CAE or CFD areas, most of the engineers can divide their areas of interest into some segments. Like they can go for machine area. Normally, after completing bachelor degree, the people usually given meshing kind of jobs, because once you get fundamental knowledge on element, nodal level application, and boundary condition definition, and applying the load in the meshes, and refining the mesh, auto mesh free methods. If you see sorry, those kind of fundamental knowledge, then you will be promoted to a analyst level, so where you can use for computational mechanics in the deeper, and you can dive into multiple analysis tools, and you can compare the results based on the meshing as well as the boundary conditions. There is one more area called tool development and customization. It is nothing but not only the front end area, the back end area. You can develop the tools. You can using software knowledge. If you see computer engineers or information technologists, they can develop the front end tools for the analyst and the CAE people. So my area of interest is coming into this area, tool development and customization. So I have learned, even though I'm from mechanical engineering and MTech from engineering mechanics, I learned a lot of computational tools like C, C++, Python, scripting languages, Java, and other fundamental needs, Fortran especially. So for creating computational mechanical applications. So the here application is nothing but the software package, ANSYS, Abacus, Hypermesh kind of things. So you can develop such kind of application softwares, and you can customize the features based on the analyst and application environment need. And the work nature would be, if you are going to a measure or an analyst, it will be hands-on experience with the tools and packages, and you have to develop the tool knowledge and the domain area skill set. It could be linear analysis, non-linear analysis, acoustic analysis, or thermal analysis, or NVH, or durability, so whatever. And if you want to go for a tool development, like application development or customization, you have to strongly develop your OOPS concepts as well as the scripting knowledge. And anyway, wherever you go, CAD or CAE or CFD, we need the fundamentals of strength of materials, numerical methods, mathematics, partial differential equations, integrations, matrices, vectors, then finite element analysis, obviously statics and dynamics. And you can apply these concepts in automobile, defense and aerospace, electronics, medical devices, industrial equipments, power plant, power stations, oil and gas, architecturals, spacecrafts, whatever. There are n number of, even for mobile creation, for designing the chip and the circuit design, we need computational mechanics. For the impact analysis, when you are dropping a mobile certain height, how the crash worthiness is applied, how the impact analysis is applied. So it comes to household appliances to mobile appliances, as well as the electromagnetic fields, as well as the near field communication level. So here I conclude my this Webathon session, and I would like to thank my company Campus, then RIT Ramco Technology Webathon team for approaching me to this session. I have collected my lot of presentation things from Google, computational mechanics sites, universities, CAE and CAD tools environment. ICCMS is one of the international conference for computational mechanics and sciences. ASME, I have picked a few of the definitions as well as the points from ASME articles. I referred a few books of computational mechanics and forums. I suggest iMechanica and LinkedIn, Indian Association of Computational Mechanics, are very good platform where you can gain a lot of information and the current environment and futuristic aspects of computational mechanics. So if you have, I hope I have promptly concluded my session. It has been asked by 350. So the rest of the 10 minutes could be used for discussion. And I thanking you for listening quietly this session and watching my presentations. If you have any doubts or any industrial application level discussion or any fundamental sharing of knowledge, I'm open to answer you.
Thank you, sir. We had a very wonderful session from you, sir.
Thank you so much.
Participants are requested to ask for doubts now.
Prabharan,
Yes, sir.
participant requested to ask a doubt in the chat section.
Yeah, okay,
Chat
okay.
box. அவர் எப்படி கன்வே பண்ணுறாரு ஸ்டார்ட் பண்ணிடுறாரு அவர் இல்லைன்னா நீங்கள்
என்ன சார் இது
புரியல யார் Murthy sir.
Yes, Professor.
Sir,
Yes, Professor.
one student is, one person is asked what is the difference between CAE and CAD.
CAD. Okay. The CAD will be the new product development area. It is essentially focusing on design and development. That's all. We cannot go for analysis or whether this product could be can be useful for the society or can be used in the assembly or any further development of products. So the CAD is nothing but generating design only. But if you consider CAE, it is using the CAD product. We have to analyze the CAD product according to our needs and application, whether it could be withstanding our limits and it could be applicable to our environment. If you see factor of safety that is used in CAE, the factor of safety is not considered in CAD. Simply, I'm giving you an example. If you want to create a table, if you want to give some 50 newtons of weight impact analysis, or it has to be used for sitting or keeping any weight objects. So the design of table would be under CAD. Whether it could be used for providing a weight of 50 Newton continuously or constantly, or any impact could be happened, whether the table could withstand at that moment. So those comes under CAE. That's all.
Another one participant
I hope I have answered you.
Sir, another one participant is asking about FICO software. FICO. Can I spell correctly? FICO.
PICO.
FEFEKKO.
Okay, FICO. Okay. That is for electromagnetic fields, and I can suggest HFSS as well as few softwares developed by Altair Engineering. Could be HFSS is ANSYS, and Altair also having few software for analyzing electromagnetic field, antennas, and radio frequency assumption and simulations. FICO also one of the tool for electromagnetic field and radiation understandings. Yes, correct.
Sir, another, can you tell something about CFT, sir? CFT, the many students, many participants are asking about CFT, whether CFT is same like in the CAE tool. What is the difference CAE and the CFT, like that?
Yeah, as I mentioned, CAE, that is structural mechanics, CFD, fluid dynamics, also a huge area of interest. Yes, automotive and aerospace sector cannot be living without CFD or CAE, structural mechanics. Both are interconnected. See, if the vehicle is in the static position, not having any forces or any friction applying on that, we can consider only the structural mechanics field. A body in white or body in prime, whatever could be considered, it will be in the structural mechanics field. When it is moving, we are buying a car for driving. Okay, so if it is obviously coming into the environment, having wind flow, temperature, acoustics, NVH, all those environment. So the fluid dynamics is a glorious area of interest. That is also same kind of structural mechanics, that is CME. So both are coupled together, both are used for evolving computational mechanics. So both are having very good feature.
Another one interesting question, sir. What is the future of computational mechanics in Industry 4.0? What is
Very good.
the yes, sir.
Yes, absolutely. I mentioned that automation and mobility services, and recent days I have been working with creating digital twins for IoT platform, industrial Internet of Things. Yes, obviously I agree. There are some limitations for using computational mechanics, but the constantly it grows into different fields of industrial evolution of 4.0, and it is giving a lot of automation perspectives without handling man-made development, application, customization. The tool itself, the customized tool itself, can automate the environment, and it will bring you the results. In one of my project, we have developed fatigue analysis in an automated way and NVH in an automated way, and we could be able to achieve almost 60 to 75% reduction in time. So while going for a man-made analyst to understand, implement, and execute, then finally come for their solution, he took 8 hours. So we could be able to complete in an hour. So that kind of automation techniques are used in Industrial Revolution 4.0. And so for that, we usually go for scripting tools and scripting concepts. Yes, correct.
நான் டவுன்லோட் பண்ணிடுறேன். கொண்டு வந்துடுறேன். சரியா? ஆமாம், சேட் பாக்ஸில்.
Any other questions from participant?
சரி, ஓகே. 5 நிமிஷம்.
So most of the question already he answered the questions. Repeatedly they are asking. One fundamental question the students asking, sir, what is meshing?
Okay, meshing is if you consider a component and you could discretize into finite number of elements. If you consider a cantilever beam, or normally we used to go for a cantilever beam analysis for understanding the finite element methods and finite element concepts in the beginning. So we can divide it into a cantilever beam into if you consider a single line, you can cut that line into two pieces. So those two pieces used to call two elements. So this dividing into two elements is called meshing. Okay, I'm using 1D elements. Okay, if you go for 3D components, you can go for 3D elements, trapezoid, hexagonal, or triangular elements, or so those kind of elements could be used for with the help of meshing only you can achieve your results. A chair can be divided into 5 elements. it can be divided into 1,000 elements, it can be divided into lakh elements. So based on the elements, you will define your degrees of freedom, you will fine tune your results, you can achieve your application, and you can reach your solution easily with the help of machine.
Okay, sir. Thank you, sir. I think the participants they are giving good comments about your lecture. I think you could have seen in the your screen itself. Now I request. I think this session is over, and now I request Dr. Godwin to give thanks for the guest. Over to Godwin.
Thank you, sir. I would like to thank Mr. A. Balaganeshamurthy from Digital Engineering Services and Solutions, Chennai, for handling a wonderful webinar session, Computational Mechanics. On behalf of the Ramco Institute of Technology Management, faculty members and the online participants and the faculty members of other institutions, I would like to thank you once again, Mr. A. Balaganeshamurthy, sir, for your wonderful session. So we would like to carry your session in future also. Thank you, sir. Thank you.
Thank you so much, Professor. Thank you all. Thank you very much.
Participants, you are once again.
Mudan sir, can you share regarding feedback?
Prabhakaran, I am doing this now. You please make a.
Thank you.
Kumar sir, please wait, sir.
Yes, I'm sharing.
Participants, if you have any clarifications regarding that feedback, attendance, and other things, you can ask orally. And I have sent the feedback link also for this session now. And this.
Prabhakaran, can you able to see that slide?
Hello.
Feedback form is more different.
Hello, good evening, sir.
Yeah.
Sir, can you share the PPT, sir, for the 3 sessions for us?
After getting concurrence from the resource person through proper channel, we will share with you.
Okay, sir. Okay, thank you.
Dear participants, you just respond to the feedback for the third session. So it will be active only for 5 minutes. You just take your time and then take a note and then immediately respond to it. Today evening 7 o'clock, our team members will check all of your 3 sessions attendance, and thereafter they will give the certificate link to you. So sharply around 7 to 7:15 it will be active. So by that time you just do the process and get your e-certificate. So don't panic about morning feedback session link and all. So it is already revealed. So now you answer this feedback, you respond to this feedback, and 7 o'clock you can receive your e-certificate link. And tomorrow morning today 6 o'clock you will get one more registration link for tomorrow's session. Immediately you just respond to it based upon the first come and first serve. So we will allocate the 250 participants, and remaining now a new YouTube link will be shared. So if you are little bit late, you can able to listen the lecture through our YouTube channel. So through the YouTube channel also you can able to register your feedback, and then you can able to get the certificate also. If you are having any doubt, you just now clarify it here. No need to send any kind of emails. Don't panic. So certificate will reach you.
Sir, Amudan, sir. Sir, Amudan, sir, can you be able to hear me?
Yeah, I'm able to hear you, sir.
Sir, the certificate link will be active for only 15 minutes or there's no time limit, sir? Hello?
Amudan, sir, it will be active only 15 to 20 minutes, sir. You just please make a note, and by that time you just immediately respond to it.
So for certificate link, it will be active for only 15 minutes.
Yes, sir.
Yes, sir. Sir, hello, can you hear me?
Yeah, yes, sir.
Yes, sir. We are going to assess the participants' details, attendance details, and we will be sending the certificate link to the participants directly.
Okay.
Those who have attended all the 3 sessions, you will be getting a mail. If you are another thing, we will be cross-checking with the registered count. If you are registered,
no, sir, my question is, no, okay, that's okay. My question is whether there is any time limit for certificate link?
Yeah, there will be time limit. There will be time limit. 7 o'clock you can expect it. If you have attended all the 3 sessions, you can expect it. 7 o'clock.
Okay, okay, sir.
For everything you are putting the time limits, how it's possible, sir?
Sir,
okay.
this is only for ethical manner, sir. So now some people are doing some kind of unethical things. Anyway, you are patiently you listen the lecture, you gained the knowledge. So that's why you are the worthy fellow for getting the certificate, sir. So that's why anyway we are not limiting participants.
During this lockdown period, some of the colleges, they are asking that certificates.
Okay.
So that's why I think I'm having many of the certificates, but I attended many webinars. But our RIT people, you people only giving the for everything that there is a time limit, 5 minutes, 10 minutes,
Yeah,
something like that.
Yeah, it is a good practice, sir. It is a good practice only so that you will be active throughout the session and the process can be completed immediately.
Sir, 1 minute. No problem, sir. I'm an organizing coordinator. How much time you need for taking printout and certificate? You want how much time you need for taking the certificate, sir?
Sir, actually, I am expecting at least 15 minutes, 15 or 20 minutes.
That's what you can take
No,
it.
no, no. You people are organizing. That is your wish. In my point of view, just I said my opinion. That's all.
Okay. Your opinions are welcome, sir. Good. You are telling is good. Yeah, I really appreciate your feedback, sir. We will give some 15 to 20 minutes. Even I asked them to give some half an hour time, sir. You can take it a certificate within a half an hour, sir. 7 to 7:30. Is it okay,
Hello,
sir?
sir?
7 to 7:30.
Okay, sir. Okay, sir. That's enough. That's enough time.
Okay. The problem is that
Hello, can you
this
hear
is
me,
what
sir?
some things we cannot reveal at this location at this moment. So that is why we restricted the time. So don't panic and sorry for the
Excuse me,
inconvenience,
sir.
sir. We will do it definitely. Half an hour we will give the time for it. Amudan sir, Amudan sir, Amudan sir.
Hello, sir.
Hello. Amudan sir, you can give some half an hour time for him, sir, for them, sir.
Sir.
Sir,
Okay,
I
sir.
have
Okay,
a
sir.
time.
Okay.
I'll discuss with you, sir.
Okay. Thank you.
Okay, sir.
Thank you, sir.
Okay.
Excuse me, sir.
Can we close the session today? Is there any feedback? Open feedback. Welcome, sir. Within 5 minutes or 10 minutes from participant. Any feedback if you want to tell that in the the time itself you can tell, sir. Some open feedback. So anyway, you are going to give the feedback in the Google form. If you want to tell the open feedback, you can tell, sir. No problem, sir. We will improve it, sir.
Sir, morning itself I mentioned, sir. Today first session extended up to 11:30.
Okay.
So give 10 minutes break and then you start the second session,
Sorry,
sir.
sir. Today we have planned up to 11 o'clock. So it may be extended.
Yeah. Due to the extension, that's why I'm asking.
Extended. That is why we could not do this feedback and there is some confusions in that period. So forthcoming section, we will avoid this one, sir. Definitely, sir.
Okay. Thank you.
Thank you, sir.
Hello. Hello.
Sir.
Hello, sir.
Yes.
Hello, sir.
I can hear. You
Hello,
can
sir.
register your feedback. Yes, you are audible.
Sir, morning I have attended the first session in YouTube thing, sir.
Oh, fine.
Sir, that time I cannot fill the feedback form, sir. Now after second session and third session, I have filled the feedback form, sir.
Okay.
Can I get the certificate, sir?
Sure, you will get it.
Okay, thank you, sir.
Hello, sir.
Yes, sir, you are audible. Yes.
Sir.
Hello.
Yes, sir.
Sir.
You are audible.
Sir, I attend all the 3 sections, sir, but I not submitted first section feedback form, sir. Can I get certificate, sir?
Nothing to worry. I hope so. You have responded for the second and third. You will get it.
Okay, sir. Thanks.
So from the organizing committee, whatever the things you are faced today, any problem you faced any problem, forthcoming session definitely we will avoid that problem. So we will rectify it, sir. Actually, I know that today morning sessions are a little bit somewhat increase the time. So we will avoid it, and then we will give the right time and the right session time, sir.
Sure, sir.
Okay. Is there any feedback? Open feedback today session. Today you have faced any inconvenience, sir? Anybody faced any inconvenience? Tell me, sir. We will avoid it so that we will get what kind of problem you faced. So that if you tell this kind of feedback, it will be useful for us to improve the next session, sir. Okay, sir. Shall we close?
Time limit, sir.
Hello?
Sir, time limit for
Hello?
filling the feedback.
Yes?
The time limit for filling the feedback form, sir. Once the session was over, for continuing
It will be addressed tomorrow, sir. It will be addressed tomorrow. You will have sufficient time.
Hello, good evening, sir.
Yes.
Sir, is it possible to show the schedule of remaining 4 days, sir? That means which topics you are going to cover?
Okay, actually that will be posted in the brochure itself, sir. Have you got the brochure, sir?
Sir, that posted in the groups, WhatsApp groups, already we sent, sir.
Okay, sir. Okay, sir.
If you want, we
Thank you,
can
sir.
You
send.
check it, sir.
You tell your reply in the mail, sir. You reply in the mail itself. We will anyway. We one more poster. We will send it to you, sir.
Okay, sir. Okay, sir.
Okay.
Thank you.
Okay. Thank you.
Kumar, sir. Hello.
Yes, Amudan.
Sir, can you inform the participants that regarding the queries, regarding the availability of YouTube link and other things, what mail ID they can contact, sir? Please inform them, sir.
That is already at the very beginning of the session itself. I make it clear. So we have 50 plus available. Anyway, I just repeat again. The participants, those who registered with one particular email ID, you try to use it for all other sessions. So then only what it is easier for us to trace, and we can able to disperse the certificates. Try to use a constant email ID for your registration as well as for attending this program. Amudan,
sir.
Anything else?
Nothing, sir. Nothing more, sir.
Let me formally close the
So
meeting.
we can formally end up this session, sir.
Okay, fine.
Thank you. We'll see you tomorrow morning.
Okay, sir. Okay, sir.
Okay, tomorrow morning we'll meet at 9:30, sir. 9:30, 9:35. We'll have a session at 10 o'clock. You will have a session at 10 o'clock. You can enter at 9:45 or 9:30 so that we will start the session at 10 o'clock. Thank you. Thank you for all. Have a nice day today.
சிவா அவ்வளோது வாட்ஸ்அப் அனுப்புறீங்களா?
என்ன சிவகுமார் என்னமோ என்னமோ சொல்லிட்டு இருந்தீங்களா? என்னது? இல்லை சார், ஏதோ சொல்லிட்டு இருந்தீங்களா?
இல்லை சார், ரிஜிஸ்ட்ரேஷன் பண்ண லிங்க்கில் இருந்து இதுலேயும் வர சொல்லியிருக்கு. ரிஜிஸ்ட்ரேஷன் பண்ண ஒரு லிங்க் வேறு, இதில் வேறு லிங்க் இருந்ததுன்னா நம்ம
அப்போலாம் ஏதோ சொல்லிட்டு இருந்தேன். அந்த பிபிடிக்கா?
ஆமாம் சார்,
அது கம்மியாக ஆயிடுச்சுல.
ஆமாம், மறுபடியும் ரிவைஸ் லிங்க் அனுப்பிச்சி விட்டாரு.
சரி, நீங்கள் ஹாஃப் அன் ஹவர் கொடுங்க, என்ன பண்ணுறது?
நம்ம எல்லாருமே இங்கே தான் வந்து பிரசம் பண்ணோமா?
இங்கே வந்து பிரசம் பண்ண அவசியம் இல்லை.
இல்லை கேட்குறேன். நீங்கள்
நான் பார்த்துக்கிறேன் வீட்டை.
அதுக்கு தக்கன பிளான் ஆகிக்கலாம்ல, அதுக்கு தான்
இல்லை. அவரோட மூளை பொறுத்து இருக்குச்சு. இன்னும் 2 நாள் இருக்குல்ல அவருக்கு. நாளைக்கு நான் இங்கே வந்து பிரசம் பண்ணுவேன்.
அதான் கேட்குறேன்.
வீட்டிலனா எனக்கு பின்னாடி ஏதோ சவுண்டு கேட்டுக்கிட்டே.
யாராவது யூடியூப் லைவ் டெமோ பண்ணி காமிங்களேன், கொஞ்சம் பண்ணி காமிக்க முடியுமா?
இந்த அவர் வரட்டும், அவர் வந்தோடனே பார்த்துக்கலாம்.
உங்களுக்கும் தெரியாதா?
அவர் பார்த்துக்குவார் நாளைக்குள்ளதா? அவரு
நாளைக்குள்ளே நீங்கள் தான் பார்க்கணும்.
இல்லைஜி, அவர் லைவ் டெமோ தெரியாது. யூடியூப் எப்படி லைவ் சாட்
லைவ் ஆல்ரெடி பண்ணி வச்சிருக்கிறாரு. இப்போ லிங்க் மட்டும் தான் கொடுப்பாரு. அது ஆக்டிவேட் ஆனதுக்கப்புறம் அதில் உட்காந்து நீ பார்த்துட்டு
தேங்க்ஸுக்காண்டி கேட்குறாருன்னு நினைக்கிறேன். உங்கள் செஷனுக்கு கேட்குறீங்க.
என் செஷனுக்கு நான் இன்னும் எடுக்கல. நான் மாடரேட்டர் தான் சார். இப்போ அது லிங்க் அவங்களுக்கு அனுப்பிச்சிடுவாங்கல்ல, அது எந்த பிரச்சனை இல்லை. அவங்களுக்கு போயிரும்ல.
அதை நீங்கள் ஓப்பன் பண்ணி வச்சுக்கிட்டு நீங்கள் அது கரெக்டாக போய்கிட்டு இருக்கான்னு பார்த்துட்டு இருக்கணும், அவ்வளோதான்.
அதை பார்த்துக்கலாம். லிங்க் அனுப்பிச்சிட்டாலும் நான் பார்த்துருவேன்.
எல்லாம் பிகினிங்கில் சொன்னது தானே.
முடி நிறைய முன்னாடி வளர்த்துருக்கீங்க.
இல்லை வேற எதுவும் பாயிண்ட்
சீரியஸா இங்கே நிறைய முடி வளர்க்க மாட்டேங்க.
இவர் சார் யாருக்கு இன்ட்ரடியூஸ் பண்ணுறாரு?
இவர் சுதாக்கு பேசிக்கிறேன்றாரு. சுதார பாண்டியன் சார்.
10 மணிக்கு இவர் சார்.
சுதார பாண்டியன் நீங்கள்
இங்கே வந்துடுவீங்க தானே?
சாருக்கு வந்து மகாராஜ்.
இல்லை, நீ இங்கே வந்துடுவீங்க.
நான் இங்கே வந்துடுவேன். காலையில் நான் 9 மணிக்கெலாம் உள்ளே வந்துடுவேன்.
ஏன்னா நீங்கள் சொல்கிற போது தான் நான் என் வீட்டுக்காரையை விட்டு 10 மணிக்கு நான் இங்கே வருவேன். அதுக்கு தான்
வாங்க வாங்க, நான்
கேட்டேன். சப்போஸ் நீங்கள் இல்லைன்னா
எனக்கு நீங்கள் அதை அனுப்பிச்சிடுங்க சார். நான் பார்த்துக்கிறேன் சார்.
நான் பேசணும்.
சப்போஸ் டெக்னிக்கல் ஃபால்ட் ஆயிடுச்சு நினைச்சிக்கிங்க. நான் பேசும்போது செய்யும்போது சார் எப்படி ஓப்பன் பண்ணுறது என்ன?
இல்லை அதெல்லாம் பார்சலாக தான் சார் தெரியும். இப்போ அவர் வரட்டும், இவருக்கு தான் சொல்லித்தரேன்னு சொன்னார். இவர்கிட்ட சொல்லித்தரப்ப நான் இன்னொரு தடவை கேட்டுக்கலாம் அப்படின்ட்டு
இருங்க. அவரை கூப்பிடுவோம். இருங்க, படிச்சுட்டு இருக்காரா?
இல்லை, இந்த சிவில் டிபார்ட்மெண்ட் இதுக்கு போயிருக்காரு சார்.
இப்போ 4 மணிக்கு அவங்களுக்கு ஆரம்பிச்சிடும் சார். அதான் போயிருக்காரு.
ஆமாம். இது அனுப்பிச்சு டிஸ்பிளே பண்ணுங்கன்னா
லைட்டாக கேட்டேனமோ அந்த உள்ளுக்குள்ளே போகும்போது
இப்போ டிஸ்பிளே பண்ண டைப் பண்ணுறது ரொம்ப சிரமமாக இருக்குது. ஏன்னா கிளிக் பண்ணால் டக்குன்னு அங்கே போயிடும்.
எது
ஏன் அப்படி பண்ணிட்டீங்க? டிஸ்பிளே பண்ணிட்டீங்க
எது சார்?
அந்த
சாட் பாக்ஸ்லையும் போட்டாச்சு, ப்ளஸ் இதுலேயும் இதில் போட்டாச்சு. யூடியூப்பில்
லைவ் ஸ்ட்ரீம் இன்னும் ஓடிட்டு இருக்க மாதிரி இருக்கு.
இது இல்லை
இதில் போட்டால் யூடியூப்பில் உங்களுக்கு தெரியாதுல்ல என்ன? கரெக்டு.
லைவ் ஸ்ட்ரீம் க்ளோஸ் பண்ணிட்டீங்களாங்க?
இதெல்லாம் க்ளோஸ் பண்ணாத மாதிரி இருந்துச்சு, அதான் கேட்டேன்.
ஸ்டாப் ஸ்ட்ரீமிங் போட்டுடலாமா
சுகுமார்
சார்? இல்லை, அங்கே சிக்னல் ப்ராப்ளம் தான் சார். கேட்டுருவா
எவ்வளோ ஒருத்தர் சொல்கிறேன். ஆராய்ச்சி நீங்கள் ஏதாவது